Am I audible?
Yes, Sudhanshu, you are audible.
Okay, fine. Let's start. Okay, so fine, guys. So let's start with the pandas. So I think in last class we were talking about the pandas, and we have discussed a lot about pandas, like how we can read our files and then how we can do a data manipulation with respect to our pandas. So let's try to understand that what in all different kind of operation I will be able to perform with respect to pandas. So I'm going to open up a new notebook and let's keep it rolling. So fine, guys, in today's class, I will be talking about like how we can try to do a row-level data manipulation and a different kind of a join, merge or concatenation operation with respect to a pandas. So first of all, let's try to do one thing. So let's try to create some kind of a data. So I can try to write like from NumPy. So NumPy, I can try to write random. So I can try to import random, random, and then import, and then randn as so randn as rn. So it's completely fine. So as you can see, we are able to import it. Now what we are trying to do in this particular case, so here you will be able to find out that I'm trying to import a NumPy. So NumPy is nothing but it's a numerical Python, and I'm trying to import a random package out of that. And rn is an alias that we have given for a rand n. So now let's try to understand that what in all things or what in all kind of a data set I will be able to generate with a rand n. So rand n is a kind of a function which will try to generate a random kind of a data for you. So here, if I'm going to write down like Rn, and if I'm going to give some kind of a dimension, let's suppose if I'm giving 5 cross 4, and if I'm going to execute it, so you will be able to find out that I'm trying to generate a 5 cross 4, means a 5 row and 4 column over here. So in terms of a array, NumPy always try to generate a array, I would say, or you can try to generate a matrices as well. So here I'm trying to generate a random data set. Now, what I will do with this data is, so I will try to convert this array into a data frame. So because NumPy can understand only two things in general. So it will be able to understand either an array or either a matrices. These are the two things which NumPy will be able to understand. And if I have to perform maybe a row level operation or maybe a column level operation, yes, I will be able to perform those things even into a NumPy. But what I wanted to do as of now is, so I wanted to perform all of those operations not in NumPy. I wanted to perform all of these operations into a pandas. So fine. Here, what I will do is, so I can try to store this data maybe R into one of the variables. So it's completely fine. It's a variable which I have created over here. It's the same data. It's the same data which I'm trying to create. Now, so let's suppose if I'm going to refresh these things, if I'm going to execute it again and again, so just remember one or two data in this particular place. So as of now, it is generating 0.422. So in a first place. Now, again, if I'm going to generate, so this data has changed. Again, if I'm going to execute these things, this data has changed. So basically, a random function always try to generate a random data. Now, let's suppose, so I'm trying to generate some data and you wanted to generate a similar kind of a data. So in that case, what I should do? So in that case, how I will be able to generate a same kind of a data that you have generated. So in that case, what I can do is, so I can try to call maybe a NumPy. So let me import a NumPy as a MP. So import numpy as NP, and then I can try to write np dot random, I would say. So random random dot seed seed. Now, what is the meaning of seed? So let's suppose if I'm going to set 100 over here. Now, if I have executed, I'm able to get this data 1.74. Now, again, if I'm going to generate, data is same. Again, if I'm going to generate, data is same. Now, if you will try to perform a similar kind of operation, if you will try to take a seed is equal to same, means seed is equal to 100, which I have taken. So if you are going to consider a same seed, so in that case, you will end up generating a same kind of a data, but it's a random data. Let's try to understand these things. So here, it's not a constant data. It's basically a random data, which I will end up generating. That is completely fine. It's a random data itself, which I'm trying to generate. But even in case of a random data, if I'm looking for same random data again and again and again, so I can try to set a seed value over here. So if I'm going to set a seed value in this particular place, so I will be able to get exactly a similar kind of a data. And if you are going to take a same seed value, you will end up getting a same kind of a data. Now, seed value wise, let's suppose if I'm going to take seed is equal to this kind of a data, this kind of a number, if I'm going to consider. Now again, so if I'm going to change a seed value, for sure, my data is going to change. Now, so I can try to take seed value as anything. So seed number as anything. So it always try to generate a constant set of a random values, constant set of a random data it is going to generate. This is what a seed does all the time. So if me and you both are working on some data or maybe into some use cases and we both wanted to generate a similar kind of a random set, so in that case I can try to set a same seed, and in that way I will end up generating a same data as you. It's simply in this way it is going to work. Now, so what I will do is, my requirement is to convert this data into a data frame. So let's try to understand that how I will be able to convert this data into a data frame. So if I'm looking for a data frame conversion, so maybe I can try to import pandas as PD over here, and then I can try to write PD dot data frame in this particular place, data frame, and then I can try to pass just this data, just this particular array R that we have created. And in this way, it will end up converting my data. So my array data, which has been generated by a NumPy function or a NumPy library. So I'm able to convert those data into a beautiful data frame. It's the same data. If you will try to match these two data, you are going to get same thing. Now, that is one thing. This is what we have done. But what I want is, so I wanted to give my own row indexes and a column indexes, or I wanted to give my own column name and a row name. As of now, you will be able to find out that my column name is 012 and then my row name is again 012. So basically I have not given any kind of a row name, I have not given any kind of a column name, and that's the reason. So it is going to start from 0. But no, I want to give a row name, I wanted to give a column name over here. So if I wanted to perform this kind of operation, so again, it's very easy. What I can do is I can try to create a list. Maybe I can try to create a list variable, and then as a row name and as a column name, I will be able to set those list variable as a row name or those list variable as a column name. Now, how many rows we have? So we have 5 rows. How many columns we have? So we have 4 columns. What I will do is, so I can try to create maybe a row variable over here, and I can try to create a list. So basically I'm looking for a 5 data over here. So maybe A and B and maybe C I can try to create, or maybe I can try to create A, B, C, D and E. So I can try to create E over here. This is a row and as a column value. So this is just a simple normal list variable I'm trying to create, nothing fancy, nothing else. So I can try to create maybe X over here, and then I can try to create Y, and then X, Y, Z maybe I can try to create. And then maybe I can try to create one more variable because I have a 4 number of column. So I can try to create maybe W over here. So it's completely fine. I have created 2 lists over here, just a 2 list which I will end up creating, or I will end up generating. Now what I will do is I wanted to name all the rows and all the columns which is available inside my data frame. So it's completely fine, not an issue. So I can try to call pandas pd dot data frame over here, and if I'm going to perform this kind of operation, so I can try to pass my data. So data is nothing but it's a small r, and then I can try to provide my index value. So index is nothing but, so I wanted to give row variable which I have created as an index, and then as a column, so I wanted to give maybe I can say I wanted to give maybe a COL over here. So now if I'm going to execute it, you will be able to find out that I will end up generating a data frame with my own column name and with my own row name. So it's completely fine. It's completely possible that you will be able to create a row, you will be able to create a column name for a particular data frame that you have generated from NumPy array. So I have just generated a random data, and then on top of that, so I'm able to perform this kind of operation. Now, if I wanted to access maybe some kind of a column, so I think we have already discussed about those things. So maybe I can try to create a df variable, and inside a df variable, so I can try to store all of those values. So df, it's completely fine. Now, if I'm going to do maybe a df of x over here, so df of x over here, so x is nothing but it's a row. So it's completely fine. I will be able to get these data. So from a X column, if I'm looking for a multiple column, so maybe I can try to provide a list of a multiple column over here, and then I will be able to get my data in the same sequence. So it's completely fine. I'm able to get a data. Where is a problem? So I think I have made some kind of a mistake. W is not in index. And let me check these things. I think I have taken a W capital, and now it will be fine. So I'm able to extract a row, I'm able to extract a column value out of this particular data set. Now, I wanted to perform some different kind of operations over here. Let's suppose. So let's suppose if I wanted to create a new column in this particular place. So maybe I can try to write like a df, and then I can try to give a new column name. I think we have already discussed about these things. And the new column that we wanted to create, so new column should hold a value which is a summation of maybe a w column plus maybe a z column. Let's see. So Z column I can try to give over here. So it's completely fine. Now if I'm going to print my df, so I'm able to get this new column over here. So this is the new column which I have created. It's very easy. If I wanted to overwrite some of the column, I can do that as well. There won't be an issue at all. Now, so what I wanted to do is, so I wanted to know, or I wanted to drop maybe some of the row or maybe some of the column. So maybe I wanted to drop a row A, or maybe I wanted to drop maybe a new column that I have created. So how I will be able to drop these things? Let's try to understand it. So I can try to call df dot drop over here, and then inside df dot drop, so maybe I can try to give a. So a I can try to give, or maybe let's suppose I'm trying to give w. Now what I wanted to do over here, so I wanted to drop this particular w column. Now I have given data frame dot drop w, and I will be able to get an error over here. Why? We'll try to understand. So I'm going to make a mistake for sure. So here you will be able to find out that I got an error. Now what is the error? Let's try to understand this error. So it is trying to tell me that w is not defined in a axis. Now what is axis? Basically, why I'm able to get this error? Because I wanted to just drop this a w column, nothing else I wanted to perform, and I end up getting an error. Now if I'll start looking into this drop method or drop function, so you will be able to find out one parameter called as axis. Now what is a meaning of this axis? So axis simply means that, so I'm talking about a row or I'm talking about a column. By default you will be able to find out that axis value is equal to 0. And 0 simply means that I'm talking about a row. So whenever you are going to encounter axis is equal to 0, it simply means that I'm talking about a row. Again, so this particular things is going to create a confusion. So going forward, we are going to see some kind of a operation where you will just feel that, okay, so I have written axis is equal to 0, but it is trying to perform some kind of a operation with respect to a column. But no, that's not true. So I will try to convince you, I'll try to explain you those things, but yes, this is the kind of a confusion for sure you are going to get going forward. As of now, it will not give you confusion. Straightforward, if I'm going to set axis is equal to 0, it will be able to drop something from a row. Now here by default axis is equal to 0, and axis simply means that I'm talking about a row. Now, so I have given w over here, and w is a key which doesn't belongs from a row. W is a key which belongs from a column over here. So w is a key which belongs from a column, and by default, so that's the reason it is giving me that I'm not able to find out a w in axis 0. For sure it will not be able to find out w in axis 0. But what if I'm going to set, so what if I'm going to set a over here? Let's suppose I wanted to drop a row A. So if I'm going to set this particular things, you will be able to find out that yes, happily it has dropped row A. There is no issue. Happily it has dropped row A. I'm not able to find row A in my output. Now if I'll try to print my data frame again, so again I'm able to get A. So basically I have dropped my A over here, but still if I'm trying to print my original data frame, I'm not able to see that it has dropped a row A. It has not dropped the A from an actual data frame. So let's suppose if I wanted to drop, or suppose if I'm trying to make some kind of a changes into a data frame and I wanted to persist those changes, I wanted to replicate those changes permanently. So in that case, what I should do? So again, I will go back to this function. You're not supposed to remember anything, and just shift tab, simple. Shift tab, and then you will be able to find out one parameter called as in place. So by default, in place will be equal to false. Now, so what if I'm going to set this parameter as a true? So let's suppose if I'm trying to drop a row A, and here if I'm going to set my in place value, so let's suppose if I'm going to place my in place value is equal to true. So in this case, if I'm going to execute, and again if I'll try to print my data frame, now it has made a changes in my original data frame permanently. So you will be able to find out that permanent changes has been made in my original data frame. This is what, and this is where in place parameter comes into a picture. So with respect to many different methods, you will be able to find out this particular parameter, which is called as a in place. So by default, in place will be equal to false. So if you wanted to make some kind of a changes permanent, so in that case, you can try to keep in place is equal to true, or else. So this is not the only way, I would say. This is not the only way. So or else what you can do is, so whatever drop operation, let's suppose if I'm not going to use this in place is equal to true. So in that case, you can try to perform a reassignment operation. So data frame is equal to data frame dot drop. And in that way, again, it is going to perform a same operation. So it is going to override the actual variable of a data frame with a dropped data frame. This is what you can do. So these are the two ways by which you will be able to make a changes permanent with respect to your data frame. That is completely fine. Now let's suppose here I was able to drop my row A. Now let's suppose if I wanted to drop my column, what I should do in that case. So last time when I was trying to drop my column W, it was giving me an issue. It was giving me an error. Now, let's suppose if I wanted to drop W, so we all know that by default, axis value will be equal to 0, which simply means that it is going to perform this operation on a row label. Now, what if I'm going to set AXIS is equal to 1? So axis 1 simply means I'm talking about a column. Axis 0 simply means that I'm talking about a row. So last time it was giving me an issue, but let's suppose if I'm going to perform this operation, so you will be able to see that my W column has gone, and this time I'm not able to get any kind of a issue, key error kind of a issue. So it's completely fine. Now again, if I'll check back into my original data frame, no, it has not made my changes permanent. What I should do in this case, so maybe I can try to override a variable in place is equal to true, and in this case it is going to make a changes permanent, or else what I can do, I can try to perform a reassignment operation. So it's completely fine. Both the cases are completely fine. So in case of a reassignment operation, it is going to override my original variable, because df is nothing but it's a variable which I have created. So I'm just trying to reassign, I'm just trying to override my original variable, and it's completely fine. Or else you can try to put in place is equal to true. By default, it will be equal to false. So no need to remember anything, just do shift and like a tab, and you will be able to get a detail of each and every parameter which has been included in any Python, I would say, a method or a function that you are going to use. So even I don't remember any of these things. So like, yeah, by taking lots of classes, so now maybe I'm able to remember those things, but in a beginning, so yes, it is very much difficult for anyone to remember each and everything at any point of a time. So fine guys, so we are able to perform this drop operation. We are able to perform this drop operation. We have seen how we can drop a row, how we can drop a column. We have seen a delete operation as well, if you remember in last class. So del operation. And with the help of del operation, you will be able to delete only a column. But if you are going to use a drop operation, you will be able to perform a row wise delete operation as well as column wise delete operation. You will be able to drop. Now in last class, if you remember, so in last class I was talking about a ilock, I was talking about a lock, and I was talking about a ix. And in last class we have seen that ilock, lock and ix, all of them were trying to give me a same kind of a data, a similar data I was able to get row level on a row level data manipulation. So now let's try to understand that what is a difference in between a lock, in between a ilock, and in between a ix. Ix is the deprecated one. Now let's try to understand it. So lock, ilock and ix has been used to access a data from a row or a column or a intersection, and these things are very much important things which you should know, so that you will be able to perform a data manipulation on a row label as well as on a column label. So fine guys, let's try to understand. So I have a data frame over here. Now what I will do is, so I will try to write data frame.loc. I will try to write data frame.loc, and let's suppose if I wanted to access, maybe a row C over here, which you are able to see in this case. So let's suppose if I wanted to access a row C, if I'm going to execute it, so yes, this is a same data. I'm able to access. It's the same data I'm able to access over here. So row C, and again, we all know that if I'm going to access just a single row or just a single column, it is going to return me a series. It is not going to return me a call like a data frame at any point of a time. Maybe I can try to access a multiple rows. So here I can try to pass maybe a list of a multiple rows. So I wanted to access row C and I wanted to access a row B as well. Now if I'm going to execute it, yes, I'm able to get it. Yes, and again, order doesn't matter. So in whatever order you wanted to access your rows and you wanted to access your columns, you will be able to access rows as well as columns in this particular case. So yes, I'm able to get a data. I'm able to access a data. Now, let's suppose, so here we have given our own row name, and here we have given our own column name. It's completely fine. So we have given our row name is equal to ABCDE, and we have given our column name as WXYZ. This is what we had done. Now let's suppose if I wanted to access a data by its original indexes. Original means 0, 1, 2, 3. So let's try to understand that even though if I have renamed my row indexes, system is able to understand my default indexes or not. So what I will do is I will try to write again data frame.loc, and then I can try to put maybe 1, or let's suppose I'm going to put 1 over here. And I'm expecting some kind of an error in this case. If I'm going to execute it, so yes, I got an error. I have given row indexes is equal to 1, and it is going to throw me an error. It is trying to tell me that, okay, so I'm not able to understand it, basically what you're talking about. It's a typological error that I'm able to get. Now what if I'm going to write ilog over here, I'm able to get the data. It's completely fine. I'm able to access a data in this particular case. So why I'm able to get a data by using ilog, why I'm not able to get a data by using a log? So here you will be able to understand actual differences between log and ilog. So what happens over here is, so log always, LOC, if I'm talking about LOC, so LOC always works with a scene indexes or the named indexes that you have. So here I have named my indexes as B, C, D, E, and all those things. So whenever you are going to use LOC, a location, basically a location method, so with respect to a data frame, so LOC always helps you out to access a data with a named indexes, means whatever name that you have given, or if you have not given any kind of a name, in that case, it will be able to consider 0, 1, 2, 3, because that will be a scene indexes. That will be the indexes that you will be able to see in front of you. But if I'll talk about ilog, ilog is called as an integer location. So, and again, in other words, I can say that ilog always try to understand a default indexes. Here, you will be able to find out that I have given ilog of 1. So it's 0, 1, 2, 3. This is the data frame that we have. So here on a first indexes, I have this data. On a first indexes, I have this data. And yes, this is the data which I'm able to access in this particular place by writing ilog is equal to 1. So although we have already overridden our actual indexes, but still it remembers our actual indexes. It never forgets our actual indexes at any point of a time. It remembers it. And by using ilog function, I will be able to access a data, whether I'm talking about a row indexes or whether I'm talking about a column indexes. LOC always works with the named one. ILOC always works with the default one. This is the only differences that you will be able to observe with respect to LOC and ILOC. You can try to perform as many experiments as possible. You will be able to get a similar kind of a conclusion. So it's completely fine. I'm able to use LOC. I'm able to use ILOC. Again, when I'm using ILOC, maybe I can try to provide a multiple like a row indexes over here. So 1, 2, I can try to provide Again, order doesn't matter at all. So I will be able to access a data, as you can see. So if I'm trying to access a multiple rows, it is going to return me a data frame. If I'm going to access only one row without a list in which I'm going to provide my row indexes or column indexes, I will be able to get a series. Now, let's suppose I wanted to access certain maybe like a set of the data. So certain set of the data I wanted to access. Let me try to recreate my data frame in this particular place so that, okay, so I have this a DF. I'm going to use my actual DF. So actual DF, which I had created. This is the DF which I had created, and I'm going to use this particular DF. So let's try to understand it. So this is my original DF. So I will be able to perform this kind of operation on top of this DF. Let's suppose I wanted to access this data. I wanted to access this data. So how I will be able to access this data? So let's suppose if I'm able to get an intersection of these two rows, and if I'm able to get intersection of this column, I can claim that, okay, I will be able to access this data. So let's try to understand it, and let's try to extract this particular intersection of row and a column. So row wise, I have B and C, and column wise, I have Y. So if I have to access this intersection of the data, so maybe I can try to use a lock, or maybe I can try to use a iLock. So fine. So LOC, if I'm going to use, so we all know that LOC always try to understand a named indexes. So named indexes wise, ABCD and WXYZ. So what I will do is I will try to pass B. I will try to pass B, and I will try to pass C over here inside a bracket, comma. I can try to provide my column name over here. So column name is what? Column name is Y in this particular case. So I don't know, like it's a small or capital. Yeah. So column name I have provided over here, and a row name I have provided over here. So this is something which I have done. And while doing this, yes, I'm able to access my required data set. So whatever data which is available inside my data frame, yes, it's completely possible to access those data set on top of any kind of a intersection. Let's suppose I'm looking for some other intersection. So maybe I wanted to access this data, and I wanted to access this data. Simple. Or maybe I wanted to access these data, these four data set I wanted to access. Now, how I will be able to access these four data? Let's try to understand. So I can try to give my row name as A, and I can try to give my row name as E, A and E, and then Y and Z. So I can try to provide maybe like a Z over here. And if I'm going to execute it, you will be able to find out that yes, I'm able to access 0.38403. So yes, 0.38403, and then 928.788. So yes, this is the data, and 168.518. Yes, this is the data, and this is the data which I'm able to access. So accessing a data based on any kind of a intersection is not at all a big deal. I would say it's very easy, it's very intuitive. You all will be able to access this kind of a data in this particular way. Now, if I wanted to use iLock, so instead of using a lock, if I wanted to use iLock, then what I should do in that case? So we all know that default indexes will be 0, 1, 2, 3, 4 and 0, 1, 2, 3. This is the default indexes for a row and for a column. And we all understand, we all know that iLock always going to consider a default indexes. iLock never consider, I would say, a named indexes, default one. So here what I can do is, so I can try to pass maybe 0 and 4. So, okay, I'm going to pass 0, 4, and I can try to pass maybe a column over here. So maybe I can try to pass 2 and 3. So 2, 3, and yes, I'm able to get exactly a same kind of a data while doing this kind of a operation. So with the help of iLock or with the help of lock, in both the ways, I will be able to get my desired data set. It's completely fine. You're not supposed to worry about any kind of a data extraction. So whatever intersection that you are looking for, you will be able to get it. Now, even not only an intersection. So suppose if I wanted to access some data, but while accessing some data, I wanted to give some range. So let's suppose if I wanted to access a data from starting from a zeroth row, till maybe a second row. So starting from a 0th row till a second row, and all the columns I wanted to access, all the columns I wanted to access. So in that case, what I can do is I can try to write my function in this way. So I wanted to extract all the data from a 0th till 3rd. So I have to give a upper bound because upper bound will always be a excluded one. So I can try to give this one, and then I can try to write, maybe I wanted to access all the columns. So I can try to write just a column over here. So I'm not giving any starting point, I'm not giving any end point for a column over here. I have given a starting point and end point only for a row, and yes, I'm able to access a data starting from a 0, 1, 2. So I have given 0 to 3. We all know that it behaves like a range function that we have discussed in a very beginning. So it will always try to exclude an upper bound, and you will be able to access a data in this particular way. If you wanted to put some restriction, I would say even on a column. So let's suppose I wanted to access a data from column 1 till column 3, I can try to execute it. It's completely fine. I will be able to access a data even from that intersection. Let's suppose I wanted to access a data like all those data, but with the jump of 2. So means it should skip one row after another. It's completely fine. It's just behave like a range function. So what I have done, colon 2. So I'm not giving any starting point, I'm not giving any end point. So I'm trying to say that, okay, start from a 0, go till last, and then try to take a jump of 2. So exactly a same concept like a range function we are trying to implement over here. What if I'm going to give a -1? So in that case, I will be able to print a data into a reverse. It's completely fine. So even in case of a column, so colon -1, and you will be able to find out that this was my original data frame. This is my original data frame, let's suppose, and this is something that I'm able to get, just a reverse of that in terms of a row, in terms of a column. So all of these operations are very much possible, very much intuitive in whatever order you wanted to print your data. Yes, you will be able to get your data in that particular order. And these concepts are not new. So we have already discussed about a range function, and I think we talked about a range function as well, which comes with the numpy. Again, in a numpy section, so we'll have multiple such kind of functions we are going to talk about. But yes, you will be able to get a data even in this particular way. So subsetting a data is not at all a big deal whenever it comes to a data frame. That is one thing. Now, the second thing is, so here I'm able to understand lock and ilock. The difference between lock and ilock is lock always understands seen indexes, the indexes that you are able to see. Either if it is a default indexes, yes, in that case LOC will be able to understand the default indexes. There is no problem. But if you have renamed your indexes, so in that case you are supposed to give named indexes, you are supposed to give renamed indexes, otherwise it is not going to work at all. Whereas lock always understands a default indexes. Remember that, even though if you have renamed your indexes, doesn't matter at all, it will be able to extract a data based on the default indexes. One more thing, let's suppose if I have made some kind of a mistake and I have given a similar name. Let's suppose, so for a 2 row, I have given a maybe like a 3 row, I have given a same indexes AAA I have given, or maybe for a column I have given a same index name. So here you will be able to find out that index of all the rows are AAA. Now what will happen over here? So if I'm going to execute it, index is AAA. So I have a duplicate index over here. That is completely fine. I have a duplicate index. There is no problem. There is no issue with that. Now, what will happen with respect to lock and ilock? So if I'm going to call this A, with respect to a LOC function, if I'm going to execute it, it will be able to extract all the rows which is having name as A, because lock always try to perform this kind of operation on a named indexes, I would say. So yes, A is a name of 3 rows. It has extracted a 3 rows. But what will happen to iLog? So if I'm going to write maybe data frame dot ILOC, and then maybe I can try to give 0. So we all know that default indexes is not going to change. It is going to name it based on like a sequences starting from a 0, so 0, 1, 2, 3, and so on. So here, in this case, in case of a iLog, when you're going to use a default indexes, it will be able to extract a data based on the default indexes. Whereas if I'm going to use lock, so whatever, default indexes will not be a duplicate index. The index which system is going to create is like, it's not possible that those system generated indexes will be a duplicate one at any point of a time. It will be a unique indexes you will be able to get from a system side. So in this case, if you are going to use LOC, so you will be able to get all the named indexes, even though if name is same. So yes, just like me. So I will be able to get AAA indexes. But if I'm going to use iLog, so in this case, for sure, I will end up getting just a unique one for sure. So yes, I'm able to access 0 and 1. It's completely fine. I'm able to access it maybe. And let's suppose if I'm able to access AAA, and out of that, again, I'm looking for just a first one. So maybe I can try to write LOC, ILOC over here, and ILOC of 0th one. In this case, I will be able to get just a first data. It's completely fine. So I can try to perform LOC of ILOC in this case to extract a first data set, and it's going to work fine for me. So ILOC and LOC, just you have to remember it, that ILOC always works with the default indexes, LOC always works with the named indexes. Now the next operation I'm going to perform is a IX, because this is the operation which I was trying to show you. So let's suppose if I'm going to give name as A. So first of all, you are going to get a warning. First of all, this is the warning that you will be able to get. No need to worry about this warning. So this is just a deprecation warning or future warning that you will be able to get. So warning is not an issue. Yes, if you are able to get an error, that is an issue. So here you will be able to find out that IX is a deprecated one. Maybe in our upcoming version of the Python, they are not going to keep this IX, because I'll show you why. I'll show you why. So you don't need IX. When you have iLog and log, so you don't need IX. So see, in IX, I was trying to give a named indexes. Yes, I'm able to get a data. Now in IX, if I'm going to put a default indexes, yes, I'm able to get a data. So IX is a combination of both. IX is a combination of LOC and ILOC. So IX will be able to understand automatically that whether I'm talking about a named indexes or whether I'm talking about a default indexes. And signature of this IX is exactly same. It's not going to change at all. So whatever operation I was trying to perform with respect to iLog, suppose I wanted to extract all the rows, I would say, with a jump of 2, and I wanted to access maybe some column over here. So maybe column 1 and 2 I wanted to access. Yes, I will be able to access an intersection. So exactly same thing. Let's suppose I'm going to give a combination of a named indexes and a combination of a default indexes. Row wise, I have given combination of a default indexes. Column wise, I'm giving a named indexes, and let's try to understand whether it is going to work or not. And yes, it is working. So like I told you, IX is a combination of a lock and iLog. Lock always understands a named one. iLog always understands a default one. IX understands both, I would say. And you can try to give a combination as well. IX will be able to understand it. But if I will try to perform a same operation over here, so let's see whether it is going to work or not. It will not work, because W is my named indexes. W is not a default indexes. So it will not be able to understand inside a lock. So these combinations are not possible, named and like a default one inside a iLog or lock. In iLog, so you are always supposed to give just a default indexes. In lock, you're just supposed to give a named indexes. So this is a kind of a situation that you are going to face for sure when you will try to perform this kind of a operation. But yeah, so IX maybe in a future version of a Python, these things will not be available. Now, next thing, let's try to perform. So I have a data frame over here, completely fine. Now, if I'm going to write data frame greater than 0, if I'm going to perform this operation. So in this case, what you will be able to get is, if I have written data frame greater than 0, so it is going to apply this particular operation on each and every element which is available inside my data frame. Now, wherever my value is going to satisfy this condition, means wherever value is greater than 0, so you will be able to find out true. Whenever value is negative, whatever condition I've written, negative, positive, doesn't matter, whatever condition that we have stated over here, so it is going to give you true and false. So like if it is not going to fulfill this condition, it is going to give you a false for sure. So this is what happens in case of a data frame greater than 0 if you are going to write. So if you are going to perform some kind of a conditional operation, so this is what you will be able to get. I can maybe try to write like a data frame greater than 2. So it's completely fine. Wherever my value will be greater than 2, so it is going to return true. And wherever my value will not be greater than 2, so it is going to give me basically a false. Now, let's suppose if I'm going to pass this condition, data frame greater than maybe 0, greater than 0 or lesser than 0 or equal to, doesn't matter. So greater than 0 or greater than 1. So what will happen over here is, so if you are going to pass these things inside a data frame selection, because so far so forth what we have been doing, so we were trying to pass a column name over here and it was able to filter out a column name. But if you are going to write a condition on a data frame, and inside a data frame if you are going to pass these things, so based on that condition it is going to return you a data, and wherever a value will be equal to false, means wherever this particular operation is going to return you a value is equal to false, it will try to replace these things with NaN, not a number basically. So it's kind of it's equivalent. It's not equal to, but it's equivalent to a null value. You will be able to understand. So this is what, and this is how you will be able to write a condition on top of a entire data frame. Now let's try to understand that how I will be able to perform a row label filter operation or maybe a column label filter operations over here. So what I will do is, so this is my data frame. This is my data frame. This is the original data frame which I have created. I can try to write df.loc, let's suppose, and we all know that loc understands named indexes. So maybe I can try to pass A. Maybe I can try to pass B over here. So B is another row name, and maybe I can try to pass C over here if I'm going to do greater than 0. So what this operation will do, this operation is going to select, this operation is going to return a data frame. That is true. So this operation is going to return a data frame, and then I'm trying to perform this operation. So again, true false kind of a value that you will end up getting. It's completely fine. Or I can try to exclude A because I have named just 3 indexes as A. So B, okay, I have just missed this quotation. B and C, DF, okay, B is not there. I have just overridden this B by, so let's suppose I'm going to access D and E. So it's completely fine. Same thing I'm able to get. Now if I'm going to pass inside this DF, just like a previous operation that we have done, now what? So you will be able to get a data. You will be able to get a data frame. You will be able to get a data frame based on these conditions. So rest of the value will be equal to none because I'm not doing a selection over here at all. So this value will be equal to none. And wherever this is going to return a true value, you will be able to get a data. And wherever it is not going to return a true value, you will not be able to get a data at all. So this is some kind of operations that you will be able to perform. Now let's suppose I wanted to perform some other kind of operation. So let's suppose if I'm going to do a selection operation. So this is my original data frame. Now I wanted to perform one thing. So I wanted to extract only those data. I wanted to extract only those data where X is greater than 0. So, or I wanted to perform an operation where value of X column or value of X column is greater than 0. Means I wanted to extract this, I wanted to extract this, I wanted to extract this row, I wanted to extract this row. So if I wanted to perform these kind of operation, means I wanted to access this row, this row, this row, and this row. So how I will be able to write a condition? So far, so forth, we were trying to write a condition on a data frame. Now let's try to understand that how I will end up writing a condition on a column label. So what I will do is I will try to perform a selection operation of maybe X. It's completely fine. I can try to use lock ilock as well, but this is the simplest possible selection. So yes, I'm able to get X. Now I can try to write X is greater than 0. So what will happen? It is going to return me true, true, false, and true, true. Now let's suppose if I'm going to pass this particular operation inside my data frame. Now what will happen? So this is called as a filter operation. So automatically it has filtered a data. Automatically it has filtered a data where it is not going to satisfy this kind of a condition. So this is how you will be able to perform a operation, I would say. So it is able to filter out only those data selection where it is going to satisfy this condition. Maybe I can try to put like greater than 0 and greater than 1. I can try to put none of the data is greater than 1, I would say. So greater than maybe 0.3 I can try to put. So this is the only data where my X is having a value greater than 0.3. So in this way, I will end up writing a condition. Now let's suppose I wanted to write a multiple condition. What I should do in that case? So if I wanted to write a multiple condition on multiple columns, so I wanted to filter out a data where column X is having a positive value as well as column Y is having a positive value. Means what? So means I wanted to filter out a data where these two columns is having a positive value. So yes, here both of this column is having a positive value. Here no, here no, here no, and here yes. So I wanted to access maybe E and A. So how I will be able to write a multiple condition over here? So let's try to understand. You can try to write any kind of a condition, doesn't matter at all. So let's suppose if I wanted to write this condition, so I can write in this way, data frame, and in a bracket, so I can try to write condition number 1. So I wanted to write where X is greater than 0. X is greater than 0. And then I wanted to write a condition. So I can try to write like a AND. So this is the AND operator. So it should satisfy both the condition. So X column should be greater than 0 as well as Y should be greater than 0. So I can try to write in this way. So data frame of maybe Y is greater than 0. So greater than 0. So, okay, I think I have missed something over here. Key error, so it is not able to understand Y. So okay, Y is in a small case. So now it's fine. Here you will be able to find out that yes, based on both the condition, if both the conditions satisfies over here, so based on both the conditions, so it is able to filter out my data. So it's completely fine. I'm able to get it. Likewise, I can try to write hundreds of conditions, doesn't matter at all, and I will be able to get a data very easily, I would say. So I will be able to do a data selection based on any of the condition that we are going to write. Now let's suppose, so based on this condition, so I'm just expecting a W column. So it should apply this condition and finally should give me only a W column value. Not a problem. So I can try to select this W column and here I just have a W column. It's completely fine. I'm able to get it very easily in this particular case. So this is how you will be able to extract a data, or you will be able to write, basically you will be able to write a condition on top of these. So the next operation which I'm going to perform on the same data frame is, so this is my original data frame. Now, so as of now, I have given index is equal to AAAADE. So this is the indexes which I have given. Now let's suppose I wanted to change this indexes. Let's suppose I wanted to change this indexes. So let's suppose what I wanted to perform over here is, so I wanted to treat this Z column or maybe Y column as an index. So whatever value we have over here, so I wanted to treat this value as a index, not a part of a data frame. So I wanted to change all of those indexes which is available or which I have given. So how I will be able to change our indexes? So let's try to understand it. So before that, so let's try to understand that I have given our indexes over here. Now, so I wanted to get a default indexes. I'm not interested in this indexes which I have given A, D, and E. So I'm not interested in this one. So I wanted to get back my original indexes 0, 1, 2, 3, and all those things. So I can try to call a data frame, and then there is a function called as reset indexes. You will be able to find out. Now, if I'm going to call a reset indexes on top of a data frame, you will be able to find out that it has done a reset operation. Now it is trying to print my 0, 1, 2, 3, 4 along with my existing indexes which I had given. No, but what I want now is I don't want to see these things. I don't want to see these things at all. So I just wanted to see my default indexes. That's it. So in that case, what I should do, so let's try to find out some kind of a parameter which is available inside a reset indexes. So if I'll just do a shift and tab, so you will be able to find out that there is a parameter called as drop. There is a parameter called as drop, and by default drop is equal to false. So if I'm going to set, let's suppose if I'm going to set drop is equal to true over here, TRUE over here. Now your actual indexes, the named indexes that you have given is gone. So now I'm not able to see my AAA on DE kind of a thing over here. So now I'm able to see just a default indexes. So this is how you will be able to reset the indexes. And this is like a pretty much useful function that you will be able to get. Now let's see if I'm going to print this data frame. So whatever changes I have done, it is not reflecting those changes in my original data frame. I wanted to reflect those changes, and I think I talked about this operations. So you will be able to find out another parameter called as in place is equal to false, and this is the same parameter we have observed even in case of a drop operation. So if I have done something, if I wanted to make my changes permanent, so in that case either I am supposed to override the variable, so df is equal to this value, I can reassign, or else I can try to call in place is equal to true over here, and it's completely fine. Now if I'm trying to print my data frame, changes has been done permanently with respect to my data frame. I'm able to reset my indexes to the default one. Now what I wanted to do is, so I wanted to set some indexes. So I wanted to I wanted to treat this column Z. So reset indexes we have done, we have seen. So I wanted to treat this Z as a indexes. Now I'm not liking my default indexes. I'm not liking this default indexes. So I wanted to I wanted to treat this particular column as an index. I don't want to treat these things as a data. So what I should do in that case? So what I can do over here is, so I can try to use one function called as data frame dot set indexes, I would say, and then as a part of a set indexes, I can try to provide my column name. Now, if I'm going to execute, you will be able to find out that Z is behaving like a index over here. Now let's try to test it. So if I wanted to access a data from this particular row, what I should do in this case, I can try to use lock or ilock. So I can try to print first of all a data frame. Now in my data frame, I'm able to see that my changes is not reflecting. What I should do in that case, simple operation, either reassignment or in place is equal to true, true. So it's completely fine. My changes has been done permanently. Now, if I wanted to access a first row, so I have multiple ways. I can try to use LOC. Now, LOC wise, I'm supposed to provide this index name over here. And let's suppose if I'm going to provide this index name, I'm able to get an error. And what is a reason behind this thing? So I'm supposed to understand that particular part as well. A reason behind these things is you are able to see this value. You are able to see this value, but this is not an actual data. I have generated a random data, if you remember over here, and it is trying to show you only a 6-digit. That is the limitation of a data frame, but this is not an actual 6-digit, I would say. So if I would like to access some data in the form of a numpy, let's suppose if I wanted to access only this data, so let's try to do maybe df of ILOC, and ILOC wise, I wanted to access the data from a 0th indexes, and then of 0 if I wanted to access. So this is my actual data. You are just able to see, you're just able to see what? You are just able to see a sixth digit over here, but no, that is not your actual data. Whenever NumPy used to generate, so this is at whole data length, and what I have given over here. So my operation is completely correct. My operation is not wrong. There is no problem with my operation. It should be able to get the data, but the indexes which I'm trying to give is wrong. So first of all, I'm supposed to get an exact index. Unless and until I'm not able to print the exact indexes, I will not be able to get the data. So here, maybe I can try to print a df.index over here. And in this way, this is the actual index value. If I'm going to pass this index value, let's try to understand whether I'm able to get a data or not. And yes, I'm able to get the data. So this is something that you are going to face when you are going to generate a data with the NumPy. So whenever NumPy generates a data, so in terms of a data frame, it is not going to show you, or in terms of an array, it will not show you the whole number, the whole digit which it has generated. It will just show you a first six. And again, there is a function by which you will be able to chop off to some certain decimal points. That is possible. But here, when you are trying to access it, unless and until you don't know that what is the actual numbers till last, you will not be able to access it for sure. So this is what I'm trying to do. It's completely fine. Or else what I can do is, so I can try to maybe create a list, and then list of the name I can try to create. So maybe SUDH I wanted to create KUMAR, I wanted to create maybe ABC over here. I can try to create XYG over here, XYG over here, and then maybe I can, okay, instead of doing this, I can try to perform some other operation as well. So I can try to create one string actually, SUDH, KUMAR, and maybe ABC I can try to create, XYG I can try to create, XYG I wanted to create, and okay, so WCV I can try to create. So this is the string I have created. Now I wanted to treat this SUDH, KUMAR, ABC, XYZ, and WCB as a indexes. How I will be able to treat these things as a indexes? Let's try to understand it. So what I can do is I can try to create. So this is my original data frame. I can try to create a new column over here. So if I have to create a new column, so maybe I can try to give a column name as maybe n over here, a small n, and then the value will be nothing but, so L dot split, and then we all know that if we are going to split up, if we are going to call split on top of some string, so it is going to return me what? It is going to return me a list of the data. We have discussed these things in a very beginning. I think you all are using it, I would say. So if I'm going to perform this operation, if I'm going to print this df, so I have end up creating one new column where I have SUDH, KUMAR, ABC, XYG, and WCB on all those things. So simple, it has splitted my data based on space. By default, split understands space as a delimiter. If my data set is separated by comma, I can use comma. There is no issue with that. It's completely fine. Now I wanted to treat this n column as a indexes. So maybe I can try to do one thing. So set indexes and I can say set indexes, and I can try to treat this n column as a indexes. It's completely fine. This is the indexes which I'm able to get. Now again, if I'm trying to create call my data frame, so it has not done a changes permanently, so maybe I can try to call in place is equal to, I would say true, and if I'm going to print my data frame, so yes, now it is trying to treat these things as a indexes. So it's completely fine. We all know that how I will be able to get a data based on the named indexes. So I can try to write like df.loc, and then I can try to write SUDH. I'm able to get the data. So I'm able to get these particular data in this particular case. Now, if I wanted to access a data from a multiple row, so it's the same old story. I'm trying to reiterate. So I can write maybe ABC over here, and yes, SUDH ABC. So I'm able to create a new column. I'm able to assign that new column as a indexes, and then I'm able to access a data. That is completely fine. Even in this case, if I wanted to access a data based on maybe like default indexes, we all know that I can try to use maybe a default index value over here, and with the help of that, so I will be able to get a data. So I am supposed to use basically iLock in this case. It's completely fine. I'm able to get same data set in both of these cases. So I think we are like pretty much good with all of those operations that we have discussed so far so forth. Now let's try to perform a few more operation on this pandas data frame, I would say. So let's try to like perform these operations. So what I will do is I will try to create a new data frame this time. So let's try to create a new data frame. So let's suppose I'm going to create a df1, and df1 is nothing but so pandas dot and data frame I can try to consider, and inside that I can try to take a dictionary. So I have a dictionary, let's suppose, and I wanted to complete, or I wanted to convert a dictionary into a data frame. So we all know that dictionary is going to consider what? Dictionary is going to consider key and value. So maybe I can try to take key as a, and then value wise I may take maybe 1 comma 2 comma np dot nan. So nan is nothing but a null value, and then I may create another key. So I can try to create a b, and its value is nothing but so maybe like 5 comma np dot nn value. I wanted to create nn value, so np dot nn, and again one more values np dot nan I can try to create, and then I can try to create another, I would say, a key, and value wise so I can try to assign this value. So maybe like np dot nan is the first value, second value is 5, third value is np dot nan. Now execute it. If I'm going to print data frame 1, this is something that you will be able to get, because we all know that if we are going to pass a JSON data, or if we are going to pass a dictionary kind of a data, so key it is going to treat as a column indexes, and then it is going to create a data. Let's suppose in one of the value we have some extra value. In that case you will be able to get a issue. So make sure that whatever value or whatever value collection that you are going to take, so all those value collection must be having a similar kind of a data. So this is our data frame that we have end up creating. Now what I have to do, so whenever you will work with a real-time data, so what happens is there will be a null value. Here I have introduced a null value, purposely, I would say. So here I have introduced a null value purposely, but in a real-time data set, for sure you will be able to get a values, I would say. So null values. Now, so sometime what we used to do is, sometime we used to drop a null values, sometime we try to accept a null values, or sometime I would say, so we try to replace those null values. That is called as a imputation. There are many various kind of imputation which is possible. So these are the kind of operation that we use to perform. So let's try to understand that how I will be. Let's try to understand that how I will be able to perform an imputation, or how I will be able to perform this a drop operation on a column level or on a row level, because this is what you are going to do for sure with respect to a original data set as well. So here what I will do is, so I will try to introduce one new function which is called as a drop na. So df dot drop na. So drop na, drop is a function that we have discussed. Drop has been used for dropping of like a row or the column. Now drop na is a function which we are going to use, and inside a drop na, so what we can write. So let's suppose if I'm going to call a drop na, and then if I'm going to execute it. So, okay, I should perform this operation with respect to df1. So if I'm going to perform this drop na, and after execution of these things, I'm not able to get any data. What is the reason? So what is the reason behind that? So it has dropped all the data. Now let's try to understand first of all a signature of drop na. Now if you will look into a signature of drop na, you will be able to find out that axis is equal to 0. Now what is the meaning of axis 0? Simple, row. Axis 1 means column. Now axis is equal to 0. So what this drop na does is, so drop na will try to drop a data if in this row it will be able to find out even if a single nn value. So yes, in my first row I have nn value, null value. In the second row I have one null value. In the third row I have all the values as a null value. So it will be able to drop the entire data set, I would say. It will try to drop entire data set over here all the rows it will try to drop. Let's suppose if I'm going to set x is equal to 1, what will happen in this case? So you will be able to find out that it has dropped all the columns as well. Now let's try to create one column where at least like we have some values. So I can try to take maybe like 7 over here. Okay, so or here I have created one row. You will be able to find out that which is having no null value. So if I'm going to set x is equal to 0, so yes, I am able to get this data, but I'm not able to get rest of the data. So on axis is equal to 0. Same thing will happen on an axis is equal to 1, column wise and row wise. So this is something that I will be able to perform. Now let's try to perform one more operation, row wise as well as column wise. So here you will be able to find out that in my first row, I have all the not null value, not null. In a second row, I have one null value. In a third row, I have 3 null value. So fine, first, second, third, it's completely fine. Now I wanted to drop, because generally what happens is even on an enterprise level, so whenever you will try to drop some rows or some columns, so we always try to consider that if there are more than 80% of null values, or maybe 10% of null values, or maybe if we have more than 5% of null value, only in that case I'm going to drop it. Otherwise, I will not try to drop it. So if this is a kind of a threshold we are supposed to apply, so how I will be able to apply those threshold? So if you will look into our information which has been given over here, shift and tab, so you will be able to find out a threshold is equal to none. Now what is a excuse me, so what is the meaning of threshold is equal to none over here? So if let's suppose if I'm going to set threshold is equal to maybe like 0 over here, threshold is equal to 0 if I'm going to execute it. So here what it will do is, so here it will not try to drop anything. Now what is the exact meaning? So let's try to understand these things from its definition. So what is our definition of threshold which has been given, so that you will not be able to forget? So it is telling me that required that many number of non-NN value, required that many number of non-NN value. What is the meaning of it? So again, it's a confusing thing. So many of you will get confused. So just try to focus over here for next 2 minutes. You will be able to understand it. You will not get confused at all. Now, threshold is equal to 0 if as set. So in this case, it is looking for 0 not NN value. So in this case, I have 3 not NN value. This case, I have 2. In this case, I have 0 not NN value. 0 not NN, not NN. 0 not NN value means I'm looking for some values over here. So yes, it is completely fine. Now, if I'm going to set a threshold, try to understand over here. Threshold is equal to 1. In this case, what will happen? So it is looking for at least 1. It is looking for at least 1 not NN value. If there will be at least 1 not NN value, it will not drop that particular row. Axis is equal to 0 I have given. So if there will be at least 1 not NN, 1 not NN value, it will not drop it again. So let's try to verify. So in this row, I was looking for at least 1 not NN value. I have 3. It's completely fine. Again, I'm looking for at least 1 not NN value. I have 2. It's satisfying the condition. In this one, so I can say that I'm looking for at least 1 not NN value, but I don't have that. All the values are NN. All the values are null. So in this case, it will try to drop it. And that's the reason. So I'm able to drop these things. Now, if I'm going to set threshold is equal to 2. So now I think you will be able to understand it into a very clear way. So in this case, it is actually looking for at least 2 not NN value. So yes, here I have 2 not NN value. Here I have at least 2 not NN value. Here I don't have like any 2 not NN value. So it will drop it. Now, if I'm going to set threshold is equal to 3, threshold is equal to 3 over here. And then if I'll try to execute. So in this case, it is looking for at least 3 not NN value. So yes, in my first row, I have at least 3 not NN value. In the second row, I was looking for at least 3 not NN value, but I just have 2. In this one, I was looking for 3 not NN value. I just have 0 over here. So it will drop this, it will drop this one. So it's completely fine. So this is a meaning of threshold. Now, if I'm going to set threshold is equal to 4 over here, threshold is equal to 4. So in this case, it will be looking for at least 4 not NN value. So here I don't have 4 not NN value. I just have 3. Here I don't have 4 not NN value. Here I don't have 4 not NN value. It will drop all those things. Simple. So this is how it is going to perform an operation. Still, if I'm going to print this DF, I would say I'm able to get like DF1 basically. So if I'm going to print DF1, I'm able to get original data, because I have not reassigned, or there is a parameter called as in place. So if you are going to set in place is equal to true, so whatever changes it is going to make, all those changes will be a permanent changes you will be able to find out. So this is what happens, guys, in this particular case. Now, so this is all about a drop NN value. Now let's try to understand that. Let's suppose if I wanted to fill those NN value with some values, what I should do in that case. So let's suppose I wanted to do a replacement of some not NN value. So how I will be able to perform this kind of a replacement? So I can try to call df1, and this time instead of calling a drop NA, I will try to call fill NA. Now, so if I wanted to fill some data, if I wanted to replace this NN value with some data, let's suppose wherever there is a NN, I wanted to replace all the NN with my name, SUDH. It's completely fine. I can do that. Maybe I wanted to replace all of those values with maybe a 5. Yes, I can do that. Basically, in place is equal to true, that changes will be permanent. Or else I wanted to perform an operation. So I wanted to take a mean of A or B or C, or maximum of A column or B column or C column, or maybe like average or standard deviations of A column, B column or C column, and then I wanted to fill all those values with that standard deviations or that mean or median. So how I will be able to perform that? So here I can write that, okay, so do one thing, try to select, I would say, try to select a column A, I would say over here, column A selection it is going to perform, and then try to take a mean of this column A. So here you will be able to find out that I'm trying to fill all the not NN value with an average of a column A. Now, what is the data we have inside column A? 1 and 2. These are the two data. Now, if you will try to find out the average of it, average will be equal to 1.5. So 1 plus 2 is equal to 3 by 2 is equal to 1.5. So here everywhere it has filled this NN value with, I would say, 1.5. I can replace these things with anything, doesn't matter at all in this particular case. So many like operations are available. You can try to find out mean, max, or maybe like minimum, maximum, standard deviations, or maybe like any kind of other operations you will be able to perform over here, and then you will be able to fill those data with these particular things. So this is how we generally like try to fill all those values. So this is something that you will be able to get. So it's completely fine, guys. So this is how I will be able to fill the value. But one more interesting thing I would like to talk about over here. This is not, we try to replace our null values in a real time. This is not an actual approach. Because here what I have done, I'm trying to take one data, and then by that I'm trying to replace all the NN value. In a real time, you will not be able to, if you will be able to do it, but this is not a correct approach of filling a NN value. Because if I have some row, if I have some column, there must be some relationship between a row and the column you will be able to find out. So whenever you are trying to fill a data with some values, you are supposed to take that relation. You are supposed to consider that relation. And in case of a machine learning, you will be able to find out that we try to perform a imputation. This operation is called as of now, I'm trying to fill the values. But in a real time, so we try to perform an imputation. So there are a different kind of a imputer which is available. Imputation is nothing but, so column wise or row wise, it will try to find out a relation in a first place, and then it will try to fill a value with that relation. Means whatever data by which it is going to replace your NN value, so there must be some relation. It's not like you will just take a mean, median of something and then you will replace it. That is not a correct way, I would say. So in a machine learning, so generally we talk about imputers, different kind of imputers. One of the famous imputer is a KNN imputer, so k nearest neighbor imputer, that we are going to use in a machine learning, not here. So here I'm just trying to talk about a data frame operation, and I'm just trying to say that, okay, so how you will be able to replace null values. But in a real time, we don't do that. Remember it. So it's not like whenever you will get some null value, just go ahead and replace it with any value. No, you should not do that. You will end up destroying the entire relationship between a data and your model. If you're going to create a machine learning model, this is not going to work for you. So it's completely fine, guys. I'm able to perform this kind of operation. Now I would like to show you group by kind of operation, or I would like to show you maybe like a value underscore count kind of a operation. So to do that, let me create a data. So if I'm going to create a data over here, so maybe I can try to create a dictionary, and here, so I can try to create maybe something like this. So name, so name is a key. I'm just creating my data, and I will then convert these things into a data frame. So data is equal to SUDH, and then again SUDH. I can try to create, and then I can try to create KUMAR, and then I can try to create KUMAR over here, and then I can try to create XYG, and then XYG again. Okay, XYG, XYG. Okay, this is one data that I have created. This is one key. Now I can try to create another key. Maybe I can name it as a salary. So salary, or I would say income of the person, income of the person. So let's try to keep these things as 100, 400, 200, 400, 170. Okay, this one. Okay, income, and then maybe we can try to create, I would say, like company. So company, I can try to create COM, and then I can try to create iNeuron, and again I can try to create iNeuron, and then maybe I can try to create DL, and then again 1, 2, 3. I should create a 7 data. So I can try to create WP. I can try to create a VG, and I can try to create a UL over here. So UL. Okay, it's completely fine. So I have made some mistake here and here. Now it's fine. So this is basically a dictionary I have created, as you can see. Now what I will do is I will try to convert this dictionary into a data frame. It's very easy. So PD dot data frame, and then pass your dictionary over here. So D, and it's done. It should be done actually. So what is a issue? So array must be a same length. Okay, not an issue. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay, so here I have like okay, so this is a data which I have created in this particular place. Now I wanted to perform some kind of a group by operation. So let's see how I will be able to perform some group by operation. So I'm just going to name this data as a df2, data frame 2, and this is the data that we have. Now if I wanted to perform a group by operation, so how I will be able to perform a group by operation, and what is a group by operation basically? Group means, so if name is similar, just do one thing. So just try to take it all together, and or we'll try to understand it, like how we can try to perform a group by operation. So I can try to call a group by, and then group by operation I wanted to perform on a name column. So here if I'm going to execute it, so if I'm going to perform these things on a name column, so yeah, it should not give me an issue. I have just made a small mistake. So here I'm able to get a group by. This is completely fine. I'm able to perform a group by operation, and it is going to give me a group by object. Now, what is the meaning of grouping over here? So I have performed a group by on name. You will be able to see that SUDH is occurring twice, Kumar is occurring twice, and XYZ is occurring thrice. Now, if I'm able to perform a group by operation, it will try to bring SUDH together, Kumar together, XYG together. This is the meaning of that. Now let's suppose if I'm going to perform maybe a group by, and then on top of that, so I'm going to perform MEA and me. Now what will happen? So here group by, and then on top of that I'm trying to perform some kind of an aggregation operation. Suppose if I wanted to know what is the aggregated income of SUDH, so 400 plus 100, so what is the aggregated, I would say, or what is the average income? What is the average income of SUDH? This is what I have given over here. What is the mean income of SUDH? So total income of SUDH is what? 400 plus 100 by 2 is equal to 250. Now, what is an average income of KUMAR, Kumar? So 200 plus 400, 600 divided by 2 is equal to 300. This is the average income. What is the average income of XYG? So 170, 457 plus 465 divided by 3. And this is what you will be able to get as an average income. So this is what I'm able to get. And you can ask me a question that it is not trying to consider this one. Why? Why it is not trying to consider these things? So I'm trying to perform basically some kind of an aggregation operation, and aggregation operation can be performed only on top of a numerical values. Here I have a categorical value. Here all those values are basically a categorical value. You can't find out a mean of INERON. You can't find out a mean of DL, WP and all those things. That's the reason. So it is not trying to give you those values. Only based on the numerical column, it is trying to give you the average. So in that case, like you will be able to find out a mean, max, or maybe if I'm looking for a summation, so I can try to perform a summation as well, and I will be able to get the value. So I'm looking for a summation of a total salary, that a total income of SUDH, it's a 500. 400 plus 100 is equal to 500. And suppose if I'm looking for like a total income of SUDH or Kumar KUMAR, so 400 plus 200 is equal to 500, and XYG, so summation of all these three values. So again, sum is an aggregation operation, and in case of an aggregation operation, so numerical aggregation operation, it is going to consider only a numerical column. It is not going to consider, I would say, categorical values or categorical column. If you are going to perform some kind of a categorical operation, so yes, you will be able to find out these particular things for sure easily. Now, so I wanted to perform some different kind of a operation. Let's try to understand that how I will be able to perform some kind of a different operations over here. So what I will do is, so I will try to show you something like a group by. So group by, and then group by operation I'm trying to perform on a name column. As we see that it is going to give me, I would say, an object. Group by, because group means what? So it is just trying to club the same kind of a value. Simple. Now based on the column name that I have given over here, that is very simple. Now on top of that, so I can perform many operations. So I think we all know about a describe operations, I would say. So DESCRIBE kind of operation. So if I'm going to perform DESCRIBE kind of operation, so this is what you will be able to get. Now what is that? Let's try to understand it. So here, this is my DF2, and on top of that, so I'm trying to perform a describe operation. So as we all know that describe operation, in case of a numerical data, by default, it try to consider only a numerical column. So in case of a numerical data, it is going to describe basically like a count, mean, standard deviation, 25th percentile, 50th percentile, 75th percentile, and a maximum one. This is what describe does. We are aware about these things. Now what has happened here, I have performed a group by. So now it will try to consider one group, two group, and three group. So it will try to perform accumulated data over here, and based on the accumulated data, so it is going to describe. For sure, this is the categorical column. So unless and until I'm not going to select only a categorical column, I will not be able to perform any kind of a describe operation on a categorical. By default, it always consider a numerical one. We know that. So it is completely fine. It is trying to perform a grouping operation. So KUMAR, SUDH, XYG, we are able to get that. Now for income column, what is the meaning of that? Here you will be able to find out two level of hierarchy. So now let's try to understand a column inside a column. So by default, it is trying to consider column inside a column. Basically, here we have a two hierarchy. I'll show you how. Why I'm saying that there is a two level of hierarchy. So here we have a income column, and for income column we are able to get what? We are able to get count, mean, standard deviation, minimum, and all those things. Now how I can confirm on that? So maybe I can try to store these things into some data frame called as data frame 3, and then if I'm going to print this df3, this is how it looks like. Now if I'm going to perform df3 of income, df3 of income, now what you will be able to get? So you will be able to get this value. Let's suppose I'm just looking for a count data. So what I should do in this case, so if I'm just looking for the count, so income of count, I can try to write COUNT and INCOME. So this is completely fine. I'm able to get that. Okay, so income and income of count, if I'm looking for, so COUNT, and here I'm able to get only a count. So I'm trying to follow basically a 2-level of hierarchy. So first of all, I will try to extract a data from an income column, and then again I will try to fire, and again I will try to call a data from a count column. So this is how column inside a column I have, and I'm able to access a data very easily. So this is how you will be able to perform an operation. So let's suppose, so I wanted to get this data. This is completely fine. I got this data. Now, so after doing this, what I will do is I wanted to access only SUDH. So let's suppose if I wanted to access only SUDH, so what I can do, LOC, we have discussed, we talked about LOC. So I can try to write SUDH over here. If I'm going to execute it, so this is what I'm able to get. Now this is going to return a series. Now what will happen? I have a row inside a row. I have an income row. Inside that I have what? I have another row. If you want me to show the output, so maybe I can try to store this data into a df4. df4 is equal to this one, and df4, this is how it looks like. Now once I'm able to extract just based on one single, I would say, a row, now it is going to give me a series because I'm just trying to extract one single row. But when I'm extracting one single row, so inside this row, I would say that for this particular row SUDH, over here, so I have this data, means I have an income column, inside that I have this data. So it is going to return me a series, and in this way you will end up generating, I would say, a multi-level of indexes. So how I will be able to get, let's suppose, a mean, how I will be able to access mean from this one, df4. So I wanted to access just a mean, or maybe I wanted to access just a max, or maybe 50% I wanted to access. How I can access it? So to access these things, first of all, I have to go through one by one. So I can try to write LOC of what? LOC of income, I would say. So income is a visible income, INCOME. So income is a visible row name. So yes, I'm able to get into this label. And now if I have to access just a mean over here, so what I can write in this particular place is again LOC of what? Of mean, and then I will be able to access 250. So if I have a data row inside a row, column inside a column, not an issue. It's completely fine. I'll just try to follow a hierarchy, and then I will be able to extract any kind of a data from anywhere. Doesn't matter at all, like what granularity. So I have a data set available inside my system. So this is what I'm trying to extract. This is what I'm trying to show you. Now, so we have extracted this data. Let's suppose. So, okay. So we have this data. Now what I will try to do is we have, my bad. Okay, we have this data. Now what I want is, so I wanted to access just SUDH over here, So it's completely fine. This is something that I'm able to get. Now this is a series. Now what I wanted to do is I wanted to convert this series into a data frame. I have a multi-level hierarchy. So I can try to write in this way, pandas.data frame, I would say, and then try to enclose these things within a bracket, and I'm able to get a data frame. Simple. I'm able to get a data frame where I have a row inside a row. I have an income and then another level of row, and then I have a corresponding value. Now I wanted to convert my row into a column and column into a row. How I will be able to do that? So if I have to perform this kind of operation, so simply I can try to call transpose operation, Transpose, not transform, transpose. So transpose operation I can try to call, and then I have just rotated my entire data, as you can see. So whatever was my row, now it's a column, and whatever is my column, now it's a row. So I'm just trying to rotate my data in this particular place. I am just trying to rotate my data in this particular place. So you can try to use capital T. Capital T, meaning of capital T is basically a transpose, or you can try to use transpose as a function. These are the two ways by which you will be able to transpose a data. So this is my original data set. So this is my original data set, and after that, this is my original data, and after doing this dot T, so I'm able to convert my row into column and column into a row. So you will be able to find out a very clear comparison over here. Now, so I can try to, like I told you, so there are multiple ways to perform this kind of a transpose operation. So if I'm going to like use a transpose as a method or just capital T, in both the case, it is going to perform a same kind of operation, nothing fancy, nothing else at all. So yes, I'm able to perform those kind of operation. It's completely fine, I would say, guys. Now df5, let's try to store these things into our df5. This is my df5, I would say. So this is my df5 again. So if I'm asking you that, okay, fine, get me this standard deviation, what I should do in this case. So now it's a multi-label of column. Previously it was a row. Previously I had multi-label of a row. Now I have a multi-label of a column. So not a big deal. I will be able to extract a data one by one. So I can try to write income, income, and this is going to give me this one. And then out of that, so I can try to, maybe I can try to access STD. It's completely fine. Or else if I wanted to access 25 percentile, let's see whether I'm able to access it or not. So yes, I'm able to access it 25 percentile. Anything is possible. Anything and everything is possible. So here I'm able to access a data easily. I just should know that, okay, so whether my data set is available into a row format or columnar format, and if whether I have a nested row or whether I have a nested column. In both the cases, you will be able to get a data very easily, not a big deal at all. So this is something that we have created over here, easiest possible way as you are able to find out. So these are some kind of a data manipulations that you should know and you should practice. Likewise, there are hundred thousands of ways which is possible to perform a data manipulation. But the core thing is you're not supposed to learn or remember everything. You're not supposed to do that. You should just know that how I will be able to extract what data and what kind of operations I will be able to perform. This is one of the way which I'm trying to show you, but this is not the only way. Going forward, you will find out, you will figure out that there are thousands of ways by which I will be able to perform just a same operation. So it will come with the practice. That's the reason. So we have given you Pandas practice assignment, and in that practice assignment, so we are trying to keep variations. We are giving you some kind of a complex data as well. If you have looked into your Pandas practice, because we have already updated your dashboard, in that Pandas practice, we are giving you, I think, three practice session plus one assignments we have given you. So if you will try to complete it, you will figure out, you will find out that you will be able to perform many variations, many different kind of operations. Some of the operations which I have not discussed, even those operations you will be able to perform. It's just a common sense. And once you will get a hands-on within some days, I think you can do any kind of a data manipulation on top of that. Now, so the next thing which I will be talking about is a concatenation operation, merge operation, and join operation with respect to a data frame. And to do that, first of all, I have to create a data frame, I would say. So what I will do is, so I will try to create a data frame over here. So let me create a data frame first of all. So DAF, so maybe a DAF1 I can try to create. And if I'm trying to create a data frame, so pandas dot data frame, and then maybe I can try to create a dictionary over here. So let me keep these things neat and clean. So here I can try to create maybe a column A, and for column A, I have a value, I would say like a 2, 3, 4, 2, 3, okay, 5 values. and then I can try to create maybe a column B over here, and then for column B, so I can have a value, some random value I'll take. So 5, 6, 7, 8, 9, and let's suppose I'm trying to create another column. So column C, let's suppose. So C I'm trying to create, capital C. So 3, 45, 56, 12, 34. Okay, so this is something that I've created. Now what I wanted to do is, so I wanted to close this dictionary, and I wanted to give maybe a indexes. Index is equal to, so I wanted to define my own indexes. I don't want to take a default indexes 0, 1, 2, 3, 4. This is the indexes which I have defined. So it's completely fine. If I'm going to execute it, so it is giving me an issue. Where is the issue? Let's try to figure it out. Invalid syntax. Okay, not an issue. I'll fix it. 1, 2, 3, 4. Okay, invalid syntax. Index is equal to this one, and 1, 2, 0, 1, 2, 3, 4. Line number 4. Okay, this is something which I have mistaken. Okay, that's fine. So I was just missing one simple value. So DAF 1. So this is my data frame which I have created. Simple. From a dictionary, this is the data frame which I have created. As simple as that. Now what I will do is, so I will like to create another data frame. So I can take a copy of it, and then I can try to create maybe a data frame 2, and index wise I'm going to change the indexes. So I have taken index from 0, 1, 2, 3, 4. So I can try to take maybe indexes like 5, 6, 7, 8, 9. So it's completely fine. I can try to name these things as a df2. So this is the another data frame I have created. Column is same. You will be able to find out just indexes is different. So it's completely fine. Now I can try to create another data frame over here. So maybe I can try to create a df3 in this particular case, and index I will change just an indexes. So 10, 11, 12, 13, 14. So this is indexes I have created df3 over here. So df3. So I have created basically a data frame 1, data frame 2, and data frame 3, and index wise 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10, 11, 12, 13, 14. So this is our sample data frame which I have created. Now what I will try to do over here is, so I will try to perform some kind of a concatenation operation. So concatenation is nothing but, so just trying to like arrange the data set. How? Let's try to understand. So I can try to call maybe pandas.concatenate. So concat, and then inside that, so I can try to provide maybe my data frame. So daf1 I can try to provide. I have already created it. Now daf2 I can try to provide. I have already created it, and daf3 I can try to provide. Now if I'm going to execute it, you will be able to find out this data frame. See, I have provided 3 data frame. Now what happens is concatenation happens into 2 ways. Let's suppose I have a D1 data frame, I have a D2 data frame, I have a D3 as a data frame. So whenever I'm trying to concatenate, so I can try to concatenate D1, D2, and D3 into a vertical direction. That is possible. If I wanted to concatenate into a horizontal direction, D1, D2, D3, that is also possible. So in terms of a vertical direction or in terms of a horizontal direction, so I will be able to perform a concatenation operation. So here I have called a concatenate, a concat, but I have not assigned a direction over here. Now let's try to understand that what is the kind of a direction it is trying to understand by default. So if I'll try to show you, so by default axis is equal to 0, means row. So it will try to concatenate by df1, df2, df3. So one after another, I would say by using, I would say like a row label, means it will try to concatenate vertically, I would say row wise. So one data frame, then another data frame, then another data frame. So this is how it is going to perform the concatenation operation. Now if I'm going to set axis is equal to 1, now axis is equal to 1. Now you will be able to find out that this is how this has done the concatenation. Why I'm able to get this kind of an NN value? What if I'm looking for this data frame over here and here. So how I will be able to achieve those kind of operation, let's try to understand it in terms of a concatenation, and after that for sure this concept will be pretty much clear. So as we all know that it is trying to perform a concatenation operation, by default axis will be equal to 0, and this is something you will be able to get, means it is trying to follow this particular approach. So it is trying to perform the concatenation operation row wise. Now here I have given indexes as 0, 1, 2, 3, 4, 5, 6, 7, 8. So yes, it is able to perform the concatenation. What if for two data frame, I'm going to give a same indexes. So the indexes which I'm giving manually. So if I'm going to give same indexes, I would say, so here it is going to give 0, 1, 2, 3, 4. Again, here it is going to give 0, 1, 2, 3, 4. I have a duplicate index. There is no problem, because we know that by default system will be able to understand. By default system is trying to keep your default indexes starting from 0 till n. Means by default system is trying to keep your indexes as a unique, I would say. So here if I'm going to print df, here if I'm trying to print df, so yes, this is the data that we have. Now here if I'm trying to go df.loc, so we all know that loc always try to understand the given one, the indexes that you have given. So if I'll fire 0, so on 0th indexes we have two data. So loc will try to extract these two data, because loc always understands a named indexes. So named indexes wise you can have a duplicate index, there is no problem. Now, so if I wanted to get a data from a 0th position, exact from 0th position, what I can do? So df.loc, and then I can try to type iloc over here, and then I can type 0. So now it is giving me data just from the first one. It is not giving me data from the second one. As simple as that. So depends what kind of a data I'm trying to extract. So I can use loc, or I can make use of a iloc in this particular case. Now in this case, if I'm going to use ix, which understands both, so let's try to understand what it is trying to understand actually. So by default, because I told you that ix is equivalent to, or like it's a combination of loc and iloc. So by default ix understands a named one by default, because here this time what I have done, so I have given a 0 as a named one, and you will be able to find out 0 as a default one as well. So by default ix will be able to understand a given one, a name that you have named one, I would say. So it's completely fine. Now what I will do is, if I'm going to change an axis, so we know that if we are going to change an axis, so it is going to follow this approach. It is going to follow this particular approach. So column wise operation it is going to perform. So find one, and then here you will be able to find out that index of these two data frame, index of this data frame, I would say index of this data frame and index of this data frame was same. I have given 0, 1, 2, 3, so it has done the concatenation. Index of other data frame I have not given as same, so it is trying to create a new indexes over here. Now let's suppose if I wanted to shift these things over here, so in this case what I can do, so I can try to perform, or I can try to change the indexes, and in that way I will be able to achieve a same thing. So here maybe I can try to keep an index of third one, index of this one as same. So in this case now it's completely fine. I'm able to get data concatenations over here in this particular case. In this particular case, ABC, ABC, ABC. Again, I have a duplicate column name. That is true, not an issue. So if I have to access a data from this duplicate column, I will be able to, let's suppose if I'm going to fire data frame of maybe A. So what I can expect on the A, I can expect. But let's suppose I'm looking for unique A. I'm looking for all the rows, but I'm looking for just a first A or second A or third A. So in that case, I can try to write iloc over here, and I can, or maybe I can use ix as well. So I can try to write that, okay, fine, select all the rows, and then column wise just try to select select all the rows, and column wise just select 0th column, and here you will be able to get just first A. So everything is possible. I will be able to extract a unique data. I will be able to extract a duplicate data. Doesn't matter at all. So in all the cases, it's completely fine. It just I should know that what kind of a data I'm going to find, or I will be able to get in what kind of a condition. Just it's a iloc, and I would say a lock that I have already discussed. So just old school things you will be able to find out. Again, So let's suppose if I wanted to if I, so this changes is not permanent, so this changes is not permanent. So if I, so here I'm trying to perform the reassignment operation, or else what you can do is, so maybe you can try to put in place is equal to true, and in that case you will be able to make those changes as a permanent changes. Now, so the next thing which I will be able to perform is a merge operation. So let's try to understand what is the meaning of merge. Concatenation simply means that horizontal or vertical concatenation, depends. Axis 0 means vertical, axis 1 means horizontal concatenation. This is the meaning of concatenation, simple. Now, so if I wanted to perform a merge operation, so let's try to understand that what is a meaning of a merge operation that you will be able to find out. Now, to perform a merge operation, so first of all I have to create a data. So let's try to create a data set first of all. So I will try to create a data over here. So pandas dot data frame, I would say, and then inside that I can try to take a dictionary, not an issue at all. So maybe I can try to create a key, and then I can try to create maybe a value of that. So maybe I can try to create a K0. I can try to create value wise like a K1 over here. So K1, I can try to create a K2. I can try to create a K3 in this particular place, K3. And okay, this is one key. Okay, this is one thing. Then again, so I can try to create maybe another column. Maybe I can try to create an X column over here, and X column value is nothing but, so I can try to create 1, 2, 3, 4, 5. Okay, 4 data set I can try to keep, and then I can try to create a Y column over here, and data wise I can again create 4 data, so 5, 6, 7. So this is completely fine. Now index wise I'm not going to create any kind of indexes. So this is my left table I have created. Okay, now I'll try to create my right table as well. So my right table is nothing but, so I'll just try to make some changes. This is my right table. Now, so here also I have a key, but I have basically like a key 6 over here, and let's suppose key 8 over here. So I have created basically 2 data frames. One is L, and or maybe let's suppose I'm going to name these things as df1 just to remove certain kind of confusion. So df1 is this one, and I have like a df2 over here. So df2 is this one. So I have created a df1 df2 as you can see, and in this df1 df2, so I have a 3 column. One is a key, other one is a x and y, or maybe I can try to change these things as a and then b. So it's completely fine. So in one data frame I have a key. Key is a common one in both the data frame, and I have basically like a 2 column xy, and then here I have column ab. I will try to show you a merge operation. So let's suppose based on certain kind of a condition I wanted to merge 2 set of a data. So how I will be able to merge 2 set of a data or multiple set of a data, how I will be able to merge. So let's try to understand that how merge actually works. So I can try to call pandas.merge. After that I'll talk about a join, and then I'll talk about difference between merge and join. So if we are going to pass call pandas.merge, if I'm going to pass df1 colon df2, so what will happen? What will happen? Let's try to understand it with the help of this particular things. So here merge wise, so it will try to merge data frame 1 and data frame 2. Now based on what it is going to merge. So here I have not given that based on what it is supposed to merge. So by default it will try to consider a first column, I would say. Based on that it will try to merge, or the common column that you have. Based on that it will try to merge. So I have a key column over here, I have a key column over here. So what it will do is it will try to do a matching. That okay, so I have a K0 over here and I have a K0 over here. So fine, do one thing, so merge these two. So because K0 K0 is same, so here I have a 1 4, here I have a 1 4, so it has merged 1 4 and 1 4. So XY AB, this is fine. I have a K1 over here, but I don't have a K1 in this particular data frame. So no, now there is no K1. I have a K2 over here, there is no K. So yeah, I have a K2 over here, I have a K2 over here, I have a K2 over here. So it is going to merge based on K2. So yes, it is completely fine. I have a K3 over here. We don't have a K3 in this particular place. I have a K6 over here. I don't have a K6 over there, or K8 I have over here. So K8 is not available in that particular case. So you will be able to find out that wherever it is able to find out a matching. So based on the matching, so it is going to merge these two data. Now there are different kind of a merge which is possible. So I think you might be aware of about the Venn diagram. Suppose if I have two set of a data A and data B if I have. Now there is something called as a inner join that we used to study in our childhood, or even in many subjects, even into a sequel. So we try to study those things. So let's suppose if I'm looking for inner join, so what happens in an inner join? So in case of an inner join, so it tried to merge basically two data, and it will always try to give you a result which is a common in both the data. This is called as a inner join. So inner join means it will try to give you a common data based on certain condition. So here, yes, K0 and K2. So K0 and K2 is a common data, So K0 is available in data frame 1 and data frame 2 as well. K2 is available in data frame 1, data frame 2 as well. So here it has merged based on the K0 and K2. And finally, I'm able to get K0 and K2. There is something called as a left join or left merge, L-E-F-T, left merge. So in case of a left merge, let's suppose I have a two data. So it is just going to give you all the data from the left table, all the data from the left table, and the respective data from the right table, I would say. So it will give you all the data from the left table, and then whatever matching it is going to do from the right table, it is going to give you that data. And for whatever data it is not able to do a matching, it is going to give you null value. Now if I'll talk about right join, so in that case it will give you all the data from the right table. Suppose we have two data, so it is going to give you all the data from the right table and respective data which is matching from the left table, and rest of the data will be a null. If I can talk about outer join, it will give you all the data from the right and from the left. So let's suppose this is the left table, this is the right table. It will give you all the data from the left, from the right table, and wherever it will not find a matching in right or left, it is going to give you a null value. So this is called as a outer join. This is called as a right join or / merge. So fine, let's try to understand a different kind of a right, left, and all those kind of a join operation over here. So here I'm trying to perform this merge operation. Now if I'll try to show you a parameter value, so whatever data you are going to pass as a first argument, it try to consider that as a left. Whatever data you are going to pass as a second argument, so you will try to consider that as a right. This is how left and right it understands. Simple. There is no logic behind that. First data is a left table, and second data is a right table. Now here what I'm going to do is, so by default it is going to perform inner join. This is the by default, and I would say that Pandas supports this four kind of a join which I was talking about. So left join, right join, outer join, and inner join. So by default it is going to give you inner. This is our default parameter. I will try to find out basically how is equal to I would say left. So how is equal to, I can try to change is equal to left. So now in case of a left, I told you that it is going to give you all the data from the left table. It is going to give you, so yes, whatever data I had. So if I'm going to print my df1 like so that it will be visible, so you will be able to find out that it is trying to give me all the data from the df1. So this is the df1, this is the left, I would say. Whatever coming into a first place is a left, so it is giving me all the data from the left and respective data. So if K0, so if K0 is available even into a data frame 2, it will give you a value. K1 is available into a data frame 1 in a left, so fine, it will give you all the data from the left. But if there is something which is not available into a right one, it will give you null value. So based on that, it is trying to give you all the data set. This is how it is going to perform left or right. Again, if I'm going to give you RIGST over here, so you will be able to find out that I'm able to get all the data AB from the right table. Right means whatever table I have passed in a second position, and a respective data, I would say I'm able to get from the left one. Wherever data is not matching, so it is going to give you NN, means wherever key is not matching, it is going to give you this one. Now, there is another parameter you should know over here called as on. So like I told you, so if suppose I wanted to perform this operations based on certain columns. So maybe if I wanted to do a matching on my own columns, suppose on, if I wanted to give, so try to do this matching on a key column. This is the column name, whatever column name that you are going to give. So by default, it is trying to take a key column. So this is where on will come into picture. Suppose I wanted to do a matching based on the different column from the left table and from the right table. I can do that as well. You will be able to find out a parameter called as left on and right on. So you will be able to find out a parameter called as left on. So from the left table, which column you wanted to consider, and the from right table, so what column you wanted to consider. So you can try to give that as well. So maybe I don't want to perform this kind of a merge operation on just a key column. So I wanted to consider from the left table, I wanted to consider column X, and then from a right on, I wanted to consider maybe like A. So, or maybe like a B. So if I'm going to perform this operation, so now it is trying to match, that whether from left table, I have a X column is equal to right, in a right table, I have A or not. So you can try to perform this operation based on a single column. If column name is common, I would say. If column name is different, you're not supposed to worry about that. It's completely fine. Based on left on and right on, you will be able to give a different column name as well. And based on that, you will be able to perform a merge operation. So you can give your own column, you can define your own column, and based on that, just try to perform a merge operation. This is what you will be able to get at any point of a time. Now, what I will do is, so I would like to talk about, I would say, like a join operation. So you can try to perform like a left, right, inner and outer. I think we all know the meaning of left, right, inner and outer completely. Now, I would like to talk about join operation. There is a slight difference you will be able to find out in between join, I would say. So I will be using a same data frame. So df1 is this one, and df2 is this one. What I will do is, so I will try to recreate my df1. So df1, I would like to set my indexes. I would like to set my indexes. So set index means I don't want 0, 1, 2, 3. I want my key to be a indexes. So I want to set my indexes as a key column. So as you can see, this is the key column that I have. Now my key column is a index column. This is not a column at all now. So this is index column, and I can try to make these changes in place is equal to true, so that my changes will be permanent. TRUE, true. Now, so if I'll try to print my df1, so okay, so okay, now it will be fine. So here, okay, so now my key column is basically a index, I would say. Now if I'll talk about a df, so I can try to perform same thing. So I can try to do like a set indexes. I think we talked about set indexes, and I wanted to consider my key as a index, key as a indexes, and I wanted to make these changes permanent. So in place is equal to, I can try to give TRUE, true. So it's completely fine. So this is my df2. Now merge operation wise, whenever we are trying to perform a merge operation, so we are supposed to provide a column name on which I will be able to perform a merge operation. Simple. When we are trying to talk about a join operation, so in case of a join, you are supposed to provide indexes. That's the only difference you will be able to find out in between merge and join. Apart from that, there is no differences you will be able to find out. So merge and join is a similar kind of operations in pandas. The only difference is in merge, you can try to give a column name, and based on the column name, you will be able to perform this operation. In case of a join, so you will be able to find out that you're supposed to give indexes. So here what I will do is, I can try to do df1 dot join df2. Now I can do that. My key column is same. My key column is same, as you can see, like in a both, like my index column, index name is same. So key, I would say key and key in both the places. So it is trying to perform what? So by default, it will try to perform a left join. Left means take all the data from the left and then corresponding data from the right. If there is no data in a right for a particular indexes, then replace these things with NN value. So here you will be able to find out that it has taken all the data. Left means what? A first one. So first data frame is DF1. This is what I've given. And then this is the second one I have given over here. So by default, it is going to consider a left. Now, if I wanted to know that how many kind of join is possible. So this is the 4 kind of a join which is possible. Similar kind of a merge was possible in a merge operation. Just 4, same 4. But by default, merge is going to give you what? Inner merge operation. We all know inner is nothing but common data. Left means all the data from left and corresponding data from the right. So here I can try to change these things. Maybe I can try to write how is equal to RIGST, and it is going to give you all the data from the right and then respective data from the left. Wherever it will not find a data based on the indexes, based on key that I've given. So it is going to give you this kind of a issue. Now let's suppose if I wanted to, let's suppose like if I wanted to give my own right key and a left key, or index name, right index name or left index name. So that is like commonly possible in a merge operation. Here you will be able to find out some other parameter which is called as a L suffix and right suffix. So suffix to use from the left frame overlapping column. So previously we were having a right on and left on, so here you have a L suffix and right R suffix. Simple. So it's equivalent to a merge operation. So it's completely fine. I can try to perform this like a merge operation, concatenation operation. If I'm looking for some kind of outer operation, I can perform this outer operation, OUTER operation. And outer means nothing but take all the data from left, from right, and then wherever we have a common data, give me a data, otherwise try to give me a null value. So join and merge operation is almost a similar operation. The only difference is merge is going to merge a data based on the given column name, whereas join always try to perform a join operation just on the indexes. That's the reason. So I've converted my key into a indexes, or else I can try to take my default indexes as well. I can try to call my reset index, and then I can try to achieve that operations as well in this particular case. So guys, I would say this is something I had to discuss in today's class. There are many concepts that you are going to encounter for sure. So there are thousands of operations which is possible in terms of a data frame operations. So yeah, going forward, you can try to explore it. We have given you exercise, many things you have to do to solve those exercise. So try to practice those exercise, try to achieve those results which we are expecting in your exercise or like a practice session. And let us know in case of any kind of difficulties. So this is it from my side, guys, for today's class. In next class, so I have 1 or 2 operations I have to discuss from a pandas data frame, and then I'll try to talk about NumPy in very detail. So I'll jump into a NumPy, and then after NumPy, so I will be talking about a visualization into a matplotlib, seaborn, cufflinks, and plotlib. So 3D, 2D graph, all those things I will be talking about. So fine, this is it from my side. So those who have a question, they can raise a hand, and those who don't have a question, so they can feel free to log off from this particular session. Try to ask some valid question. I think that will be better for me. Yeah, so those who have a question, they can raise a hand. Go ahead. One by one, go ahead.
Yeah, Sudhanshu, this is Rakesh Upadhyay. And just I want to ask, whenever you are trying to convert the dictionary into a data frame, always you taking the value as a list.
Okay, you want me to take some other values? Maybe
no, I didn't. I just want to put the value as a one value, like in single quotes. Sudhanshu.
So in that case, you are supposed to take one values in all the places, I would say. Otherwise, it is not going to work. Or else, what I can do is, so I can try to maybe like take these things as a string, right, as a one value, and then on top of that, so I can try to call basically split, and then I can try to give a delimiter over here. Even in this case, you will get the same thing.
Actually, what I was facing the issue is that when I hit the APIs, I get the JSON value in key value pair. Within that, I have the value like a string in place of values. So in
Okay.
that case, we explicitly put the dot split, and then we can perform the, but I want to perform the operations directly on that dictionary key values pair. So that's why I am
Yeah, you
asking.
can do that. I think in last class I was talking about JSON, and we have talked about many different kind of things. Like we had like a dictionary inside dictionary inside dictionary. Again, in some of the dictionary we just have a string. In some dictionaries, so we just have as a value we had a list. So I think we talked about. Have you attended like a last class?
Yeah, I have attended, but the only single values I haven't got any example according
No,
to
so
that.
I think no. I think I talked about that. This statement is not correct, I would say, because in the last class, okay, I have that slide. So in last class, what I have just understood in Titan 2, I think. And I was talking about like a JSON result over there.
Yeah, Jason, I have seen those, but
Yeah, here. So I have taken this kind of a JSON. So where like we have a single values, and yes, I was able to extract this data. It's completely fine.
okay,
So where is the issue?
okay.
I think this is what I have shown you in last class, right? Like
Right,
this
right,
kind,
right,
this kind
right,
of a
right.
JSON.
Sudhanshu.
So that's the reason I asked you whether you have attended a class or not, because I think according to me, I have already discussed these things in very detail. I have broken down multiple things. I have shown
Right,
you
right.
data into a
Okay,
JSON view. Just try
okay.
to go through the
Okay, okay.
previous lecture.
Thank you so much, Sudhanshu.
Hi,
I'll dig
Sudhanshu.
out this.
And Rakesh, practice is important. Unless until you will not practice, right, you
Yeah.
will not be able to understand it. So forget about whatever I'm going to teach or whatever material I'm going to share with you. Practice it. Everything is possible, according to me. Everything, whatever I can think of, I think I can do it. Simple.
Hi,
This is what I believe. Yeah,
Sudhanshu,
go
can you?
ahead.
Yeah, Sudhanshu, this is Pinak here.
Go ahead.
Yeah, so like, I mean, like fabulous class of for this pandas. I mean, like cleared all my queries. I mean, I am trying to run my operations, daily operations through Jupyter itself. I mean, like for my official work. So what actually I do is like daily I have like 3 files I have to send it to my team, and I do those operations manually, and the like merging, splitting of a cells, then doing VLOOKUP and merging again files with fine. So this class for today actually it can resolve my issues. But right now actually what I want to do is I want to operate those things in
Automated
PyCharm.
way. Okay, PyCharm. See, Notebook and PyCharm both are IDEs. So in your project section, so I think I'll talk about a PyCharm, how to debug a code, how to install a PyCharm, and then how to run a code, how to automate a code, how to deploy a code. So those things will come into picture probably next week, I would say, because next week I have a plan to cover like a NumPy, Matplotlib, couplings, Plotly, and I'll try to cover MongoDB, and I'll try to cover Flask API. So once I'll get into a Flask API, so then after that project section,
No,
I'll try to explain you.
so
Wait,
actually Sudhanshu,
wait,
not
wait,
API.
wait. First of all, yeah.
Yeah. So not
So
API.
I'll
Yeah.
try to talk about a PyCharm, and then you will be able to get those things. And I think your question is how to automate those things and how to perform those things schedule wise, right? Automatically.
Not exactly scheduleize. I mean, what exactly I want ki API is okay. I mean, like it's the next level. So like daily, I operate it in my laptop. Okay. So the pie chart, the file is there. So like I want to write a separate set of code, which actually I get it with the same format of file. So I get a file, I clean it, or I remove some columns, I remove some rows which are unnecessary rows. Then I save it in the desktop. Then I prepare a chart, and then I dispose it to my clients. So I want to write those codes and save it in a PyCharm, so that and in the same location.
See,
Whenever
PyCharm doesn't save a files. File will be saved in your local system in .py format. So
correct, yes, that's what.
yeah.
So like, so
Yeah,
I
so not a big deal. Even you can, so if you wanted to save a file just without using a PyCharm, open up your Notebook++, write a code over there, and then you can save it in a .py. Even Notebook++ support .py format. It's completely fine. And then without even using a PyCharm, so I will be able to run those things into my Python console. That is also possible. PyCharm is just an IDE. It also creates a .py file, or even without using a PyCharm, I don't need PyCharm for this particular things. So it's completely fine. I can try to like write down all those things into a .py file. I can save it, and then every day, so I can try to give a location, and based on the location, or I can parameterize it. basically.
Okay,
So I can
okay, understood,
parameterize it,
understood.
and then I can try to execute it. I
One
don't think
again,
that you need a PyCharm.
yeah.
Without even PyCharm, it's possible.
Yeah, one small doubt. I mean, like one small doubt. So we have attended the class of Virat sir regarding the chatbot. Okay, I mean the same thing actually. So what exactly? Again, my query comes to the Excel sheet that I have a load of data of daily sales and orders of my buildings. Okay, now I want to prepare a chatbot based on my Excel sheet. That would be my database. That when my user will ask anything regards to my building details, saying that last week how much is the sale for UBL1. So my that query should go and hit to that Excel database and user should get it. So is it possible, sir?
First of all, Excel is not a database. Your concept is wrong over there.
No, Excel is
Second
not
thing,
Excel is not a database. I understood. I have actually what I did is I have
I got your
copied
question,
some
Pinak.
Excel
I
data
think
in MongoDB.
I got your question, Pinak. I think you have pinged us a lot, many times,
Yeah,
and
yes.
Virat was talking about that. So see, it's a very easy operation. I think you have not tried this out. So you can try to keep all those things, because see how chatbot is going to understand. So based on the intent and entity,
Yes.
and entity, you can try to give from the Excel sheet, from the CSV file, from the TXT file, from the JSON file, from anywhere you want, right? So the only thing which you have to do is you have to update your intent and entity, right?
Yeah.
So you are supposed to like just write one single line of one single program, I would say, which will be able to update your intent and entity automatically. If you are able to do that, yes, your bot will be able to respond. This is the only thing that you have to do. So simple. So like if you're trying to use a Rasa NLU, right? So you can try to schedule your Rasa NLU in such a way that it will always try to pick and choose data from the new Excel sheet that you are trying to generate on a daily basis, and then it's completely fine. You will try to learn it, and whenever you will ask a chatbot, it is going to give you response. This is how you should follow the approach.
Okay, sir. Sure. Thank you. I will try.
Yeah. Next question, please.
Hey, Uchal.
Hello.
Okay. Yeah. Go ahead.
Yeah, this is regarding group by. Usually, group by we are getting output only if we send a command like dot sum, dot count, or dot values. But if we want to see the output only on the base of a group by of name.
So group by means what? Group by means you're trying to just merge two data, right? Now, so group by, like I told you, it's always returns a object, I would say,
Yeah.
right? So what do you wanted to see? Just I would say like the name
That object
SUDH, and like you wanted to see just SUDH, you wanted to see like XYZ, and you wanted to see KUMR, right?
No, yeah, SUDH and the respective incomes and the third
No,
column.
so group by means a respective income is what? See, I have two data over here, right? When I have performed this group by kind of operation,
Around 160
so,
cell, I guess. 160 cell.
so when I have performed this operation, so what kind of a data? Means you wanted to see this SUDH and these two data, right?
That too, I mean, whichever is respect to SUDH, that, I mean, as a
No, why
P
you wanted
will
to?
get, right?
So same thing you are able to see over here, right? So you can't. So what kind of a data it should show you? Just a data. So group by, why you are doing a group by? So purpose of doing group by is, so on a group you will perform some operation, right?
Okay.
This is the meaning of doing a group by. If I just wanted to see a data, like what is a data which is, or if I just wanted to print SUDH, KUMR, and XYZ, in that case I can try to fire unique, right? Data frame dot unique on this column. Simple in that case. Or if I wanted to see a respective data, so maybe what I can do is, so I can try to filter out the data in such a way that, okay, so wherever name column is equal to SUDH, give me those data, right?
Okay.
I can try to fire in this way. We don't need a group by in that case.
But my question is like, in first column it should be like SUDH, KUMR, and XYZ, and in the second column it should be 100 and 400 for SUDH, and it's like maybe the data will be
no, sir. I think your understanding is incorrect, I would say. So group by we are using for certain purpose. Unless and until I don't have to perform a canonical operation, why should I use group by? There is no use of group by, right? That's the reason it always returns a concatenation, it always returns an object. On top of that, you can try to perform any kind of a canonical operation, any kind of a concatenation operation, or any kind of a summation, max, mean kind of operation, so that based on the group, it will be able to perform those operations. Now, if you are just looking for the data, just tell me which data you're looking for. Like, and in a single line, it is possible to extract those data, I would say.
If we remove the dot describe from 161 cell and run, we will get an object, right?
Yeah, you will get an object. Actually.
How to visualize that object? If I pass it to pd.data
why
frame
do
of
you
that object,
need an object? Why do you need an object? First of all, tell me. So you just need a data, right? So finally you are looking for a data. Can I say that? Which data you are looking for? Just tell me. Forget about
Nothing
object
in
or
particular.
anything.
Nothing in particular. Like maybe the data in a table will be in a different locations. If we do it as in a group by, we can see it in a single location, right? So
No, sir.
even
It's not a meaning of group by actually. Group by is designed for the specific purpose. It
okay,
returns an object so
okay,
that you can perform a concatenation operation. You should understand that part. Data
okay,
wise,
but
there are other way to
if,
extract.
okay, but pd.data frame, if you send that object, it might not work. You're saying, right?
So yes, yeah.
Okay.
Yeah.
Thanks.
Okay. Fine.
Sir, one questions I have. How to make a memory efficient when we are loading the data frame?
So actually, memory efficient wise, you're not supposed to use a pandas directly. In that case, there is a substitute library which has been designed that is called as a modin pandas. So they claims that this is the new library that they have designed, and you will be able. So everything is same. So whatever we have learned into a pandas is same, but they claim that so this particular modin pandas, which is a high-level API which has been created on top of a pandas data frame itself. So it is almost 10 times faster, or sometimes it is 5 to 6 times faster as compared to, I would say, this one. So pandas, if pandas is taking maybe this much of a space, right? So modin is going to take only this much of a space. You can just try to imagine, right? It's the same. So whatever you have learned into a pandas, so exactly same thing is going to work, but processing wise and memory wise, it is much more efficient. This is how you can create. So instead of using directly a pandas, use modin pandas as a library. So it's very simple. Pip install modin pandas because it will not be available by default inside your system. So simple, pip install modin, and then you will be able to use modin pandas.
And sir, how to deal with the time series data efficiently once we get in
Again, depends whether you're trying to build a model or just trying to explore a data, right? There are two things. If you are, so in general, in time series, what you will do with the data. So unless until you're not building some kind of a model. So for time series, so there is a ARIMA, there is a SRANIMA, I would say ARMA model is there, or I would say RNN LSTM you can try to implement, GRU you can try to implement, and by which you will be able to solve a time series problem. Now, like data wise, it's completely fine. Data wise, time series data means data manipulation. Simple, right? So we have seen a datetime kind of function. So with the help of datetime function, you will be able to do a data manipulation. So you should know what you wanted to do with the help of time series data. When you say time series, like we in a machine learning, so whatever approach that I have told you, so we should talk about those things. But in terms of a model building, because what I will do with the time series data, simple data manipulation wise, I can do everything and anything, I would say. So depends case by case. So fine guys, I think we talked about a lot of things in today's class. So we'll try to conclude this class for today. Let's have a class again on Monday, and I'll try to talk about a couple of new things on our next class. With that, thank you so much. Have a great night and day ahead.